Namaste, my dear friends. Welcome back to our channel. Today, we are going to dive into a very important topic for any Java developer working with Spring Boot, Spring Security Basics. Securing your applications is not just good practice, it is absolutely essential in today's digital world. Spring Security is a powerful and highly customizable authentication and access control framework that protects Spring-based applications. In this 5-minute tutorial, we will explore what Spring Security is, why it is so crucial, and how to get started with its core features. We will cover fundamental concepts like authentication and authorization, look at practical code examples, discuss common mistakes, and provide useful tips to help you secure your applications effectively. So, grab your virtual pen and paper, and let us begin this exciting journey into application security. Alright, let us start with the first core concept, authentication. Simply put, authentication is the process of verifying who a user is. Think of it like a bouncer at a club checking your identification card to confirm your identity before you enter. In Spring Security, this is typically handled by the User Details Service interface. This service loads user-specific data, such as usernames, passwords, and roles. For securely storing and comparing passwords, Spring Security provides password encoder implementations like Crypto-Password Encoder, which hashes passwords rather than storing them in plain text. On the whiteboard, you can see a basic configuration for in-memory authentication, where we define a user details service bean and a password encoder bean. This setup tells Spring Security how to find your users and how to verify their passwords when they try to log in. It is the very first step in securing any application. Now that we understand authentication, let us move to the second core concept, authorization. Once a user's identity is authenticated, authorization determines what that authenticated user is permitted to do or what resources they can access. Imagine our club example again. After the bouncer confirms your identity, your ticket or pass might only grant you access to specific areas, like the general dance floor, but not the VIP lounge. Spring Security allows us to define these access rules using configurations within our security filter chain bean. We can specify URL patterns using request matchers and associate them with required roles. For example, only users with an admin role can access certain paths. We can also use annotation-based security, like @preauthorize directly on our methods. On the whiteboard, observe how we configure http.authorize requests to allow public access to some paths, restrict others to specific roles, and ensure all other requests require authentication. This is how you control access to different parts of your application based on user roles. Let us put these concepts into practice with a simple, practical example. We will create a basic Spring Boot application with a few REST endpoints and then secure them using Spring Security. Our goal is to have a public endpoint accessible to everyone, an administrative endpoint only accessible to users with the admin role, and another endpoint for any authenticated user. We will combine our user details service for in-memory user management and our security filter chain configuration for defining access rules. Please look at the whiteboard. You will see the complete security config class. Notice how we define users with different roles using in-memory user details manager and apply cryptopassword encoder. Then, within the security filter chain bean, we set up our authorization rules, explicitly allowing public requiring admin for admin and authenticating for all other requests. Below that, we have a simple myController class with these three endpoints. This demonstrates a complete, runnable setup for basic security. While working with Spring Security, it is common to encounter a few pitfalls. Let us discuss some common mistakes and best practices. First, a major mistake is not using a password encoder and storing passwords in plain text. This is a huge security vulnerability. Always use strong hashing algorithms like bcrypt. Second, misconfiguring request matchers or placing them in the wrong order can lead to unintended access. Remember, rules are processed sequentially, so be specific and order them from most specific to most general. Third, for stateless RESTful application programming interfaces, forgetting to disable cross-site request forgery or CSRF protection can cause issues, as CSRF is primarily for browser-based applications. On the other hand, for web applications with forms, CSRF protection is crucial. As a best practice, always follow the principle of least privilege, granting users only the necessary permissions they need to perform their tasks. These tips will help you avoid common headaches. Fantastic work, everyone! We have reached the end of our 5-minute journey into Spring Security Basics. Let us quickly recap what we have learned. We started by understanding that Spring Security is a robust framework for securing your Java applications. We explored the two fundamental pillars, Authentication, which verifies who you are, and Authorization, which determines what you can do. We saw how User Details Service and Password Encoder work together for user authentication and how Security Filter Chain allows us to define detailed authorization rules using request matchers and roles. We also walked through a practical example, securing REST endpoints, and discussed common mistakes to avoid, along with essential best practices. Remember, practice is key. Try implementing these concepts in your own Spring Boot projects. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more Java programming tutorials. Your support means a lot. Keep coding, and I will see you in the next video.